Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is one MCQ. The question is in front of you. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried. Let's start. Now question is, what is the most acidic compound among the four mentioned below? The compounds are phenol, 4-methoxyphenol, chlorophenol, and 4-acetylphenol. I know student will say, sir, it is little difficult to understand from the name. If you give these structures, then it would have been easier. I agree, that's true. But sometime in question, they don't give structure. Instead of that, they just give name. So you have to draw the structure in order to get the right answer. So I have drawn the structure in front of you. So option A is phenol, option B is for methoxyphenol, option C is for chlorophenol, and option D is for acetylphenol. So here, since it is asked about the acidity, so we need to think about the stability of the conjugate base. Conjugate base means if phenol releases one H plus, what anionic species it produces, that is called as Cb or conjugate base. Remember one thumb rule, that more the stability of conjugate base, more is the acidity. Agree? So let me draw every of the following canonical form. I am not writing everywhere proton elimination. You need to understand that acidity means here proton is eliminated, and that proton eliminated negatively charged species I am drawing, and after some time I shall discuss their relative stability. Now among these four, who is maximum stable? Means obviously that compound is maximum acidic, so it will release proton maximum efficiently. So here if you look at phenol, you may consider it's a reference compound. Now if you look at the second example, OMe. OMe means para-methoxyphenol. We know this OMe can donate some electron density inside this. By the way, how phenol is getting stabilized? Means we know phenol is weakly acidic because its conjugate base is resonance stabilized. How? So this oxygen lone pair is delocalized inside this benzene ring. Just I have drawn only one canonical form here. There could be many other. Just for your better understanding and others, it will come, it will leave, and it will produce another canonical form. So in this way, this kind of resonance will continue. I am not going. So in summary, that negative charge will be delocalized inside the benzene ring. So how this delocalization could be affected by these substitutions, that is actually the question. Now here if you look at OMe is a group having mainly plus R effect, although minus I is there, but plus R is dominant over minus I, means it is delocalized, electron donating. So it will donate its electron density inside this benzene nucleus. So benzene nucleus is already electron rich because of this OMe group. Consequently, benzene nucleus is not that much capable to delocalize the negative charge or electron density because of this OH deprotonation. So deprotonation tendency is less, fine. If you look at 4-chlorophenol, in this case the conjugate base is actually, you can consider, little stabilized compared to OCH3. Why? Because halogen also has lone pair, I agree. So 3 lone pairs, but in this case minus I effect, I mean sigma withdrawing through this carbon chlorine bond. This minus I effect arises because of the electronegative differences between carbon and chlorine that override the plus R effect. Previously the plus R effect override the minus I effect. Okay, so that's why here I can conclude that halogens are orthopara orienting because they can donate electron density to the orthopara position, but deactivating means because of this halogen or chlorine addition, the benzene ring got slightly deficient of electron. So that deficiency could be fulfilled to some extent by this negative charge on oxygen. So that's why in this case the conjugate base is slightly more stable compared to this OMe derivative. Fine. Now let's look at the last example. In last example, you can see clearly there is a OCH3CO acetyl group. So these negative charge will be completely delocalized, means it will come here, it will come here. There are many other canonical forms which I am not drawing. I am showing only the most contributing canonical forms. Okay. So in this way, the negative charge on previous oxygen is delocalized on the carbonyl group. So it means delocalization, means stabilization, and in this way the conjugate base is more stabilized here. So acidity is expected to be highest in this case because this acetyl group shows both -I and -R. Means both are withdrawing in nature, which will help to delocalize the extra charge or negative charge produced after deprotonation. So that's why option D is the right answer, or you can say it is the maximum acidic among this. By the way, if they ask what is their trend, before going to details, actually I am giving some data. Data means pKa values. If you look at phenol, it is a reference, as I told, 9.95 pKa. Next, para-methoxyphenol 10.6. OH para-chlorophenol 9.14. Just compare that para-chlorophenol is slightly more acidic compared to this OCH3, means whatever theory we have proposed that OMe has stronger plus R effect than -I, that is proved here. And if you compare phenol versus 4-chlorophenol, it is clear that in phenol pKa is higher, means less acidic compared to chlorophenol, means chlorine, this halogen has stronger -I effect than its plus R. Remember, it's very interesting. And the most acidic or winner is acetyl, so pKa is 8.05. Okay, so the order actually, if I say who is maximum acidic, D greater than obviously C, greater than A, greater than B. So this is the order of acidity. Although it is not asked, but still it may ask, so you should know. Now here, who is the most acidic compound? Obviously 4-acetylphenol. So this is the end of the discussion. I believe this video may be useful. Thanks for watching. See you in my next video. Bye bye.